Hello everyone. Today I'll be presenting my analysis of relationship between urban infrastructure complaint and the crime rate in Chicago. This project explores how factors such as street light outrage, abandoned vehicles, sanitation issue might contribute to the crime patterns across different neighborhoods. The motivation behind the study stems from the idea that negligent urban infrastructure could create environment that foster crime activities. By examining historical data from 311 service call, service request, and crime report, I aim to uncover potential correlationship that could inform policymaker, urban planners, law enforcement agencies in their effort to improve the public safety. The key objective of this research is to determine whether neighborhoods with frequent 311 service requests, such as complaint about infrastructure failure, experience high crime rates. Uh, my main research question is, does poor infrastructure maintenance contribute to increased crimes? By addressing these questions, I can provide a data-driven insight that may help cities allocating resources more effectively. Ultimately, this research aims to demonstrate the potential impact of timely infrastructure maintenance as a preventive measures against crime, reinforcing the importance of integrating urban planning and public safety strategies. Moving to the next slide. Talking about data source and the collections. For this project, I utilized two key datasets, Chicago 311 service request dataset and Chicago crime incident dataset, which are publicly available. This dataset provides valuable insight into citizen-reported infrastructure issue and crime occurrence across different communities area in Chicago. I retrieved the data from City of Chicago Open Data Portal, ensuring that my analysis was based on accurate and publicly available government data. This allowed me to examine how infrastructure complaints such as streetlight outrage, abandoned vehicles related to crime patterns in different neighborhoods within the Chicago. To effectively handle large data set, I implemented the API-based data extraction method within Python, which allowed me to automate the retrieval process and manage large record without manual downloads. To ensure I could work with thousands of records efficiently while keeping the data up to date, the dataset include important fields such as community area, service request, crime categories, and timestamps, which enable me to analyze the trend. Analyzing the trend, correlating and spatial distributions. By structuring the data for analysis, I was able to apply regressional model, clustering techniques, time series forecastings to uncover meaningful insight. Moving into the next slide, data pre-processing and cleaning. To ensure the accuracy and the reliability of my analysis, I perform a structured data pre-processing and cleaning process first. First, I addressed missing data by geospatial imputations to establish missing locations and remove incorrect records that could compromise the analysis. Both the datasets were collected from the different sources. It was crucial to standardize format, particularly by converting date column to date time format. This allowed me to perform time-based aggregations and align crime incident with corresponding 311 service request. Next, I merge the dataset based on the community area and month, creating a structure format that enabled competitive analysis across neighborhoods over time. Finally, I performed feature selections, keeping only relevant variables such as crime type, service request type, and timestamp to reduce noise in the dataset. This cleaning process ensured that all the data was structured, accurate, and ready for advanced analysis, including regressional modeling, clustering, and forecasting. Moving to the explanatory data analysis. To better understand the relationship between the crime incident and 311 service request, I conducted a explanatory data analysis or EDA. First, I examined the monthly trend in both crime incident and service request. The data show clean seasonal fluctuations with crime rate peaking in the summer month and declining in the winter. Similarly, service request followed a pattern with a spike in certain months, including possible connections between the infrastructure and the crime trends. Next, I performed correlation analysis to determine whether these types of 311 service requests, such as street light outrage or abandoned vehicles, were associated with the large crime rates. The results suggested a positive correlations, meaning that neighborhood with the um, frequent service complaint often had a higher crime levels. To visualize these patterns, I use histograph, scatter plot, and heat map, which help highlight crime spots and area with a frequent infrastructure issue. This insight provide a data-driven foundations for a subsequent predictive and clustering analysis. It is a sample uh, visualizations that I use uh, in the research. Moving to next slide, regressional analysis. To determine whether 311 service requests are linked to the crime rate, I applied linear regression analysis. This objective was to determine whether the higher number of service requests, such as street light outrage, abandoned vehicles reports, correlated with the increased crime incidents in same community area. By using a service request volume as an independent variable, crime count as a dependent variable, I was able to qualify the strength of their relationship. The result reveals positive correlations, suggesting that the area with the more service requests also tend to experience higher crime rates. However, correlation does not imply cautions. Measuring other underlying factors uh, could also be influencing the relationship. To evaluate the accuracy of the method, I calculate the mean square error (SME), which measures how well the regressional model predicts crime incident based on the service data. Additionally, I visualize the result using the regressional plot, which clearly demonstrate the trend between the two variables. This analysis provides a data-driven basis for further investigation into how improving infrastructure might help reduce crime in affected area. You can see the sample visualizations that was drawn using a Python's. It's not using the whole data because of the volume of the data. So it's this figure was drawn based on the almost 200,000 acres within the data. Clustering analysis. To further understand the crime distributions, I applied k-mean clustering to analysis to identify high-risk neighborhood based on the crime rate and 311 service request volume. The goal was to detect patterns and group areas with the similar characteristics, allowing for better insight into the crime-prone locations. The clustering results reveals Distinct high-risk clusters where neighbors with a frequent 311 service complaint also experience a high crime rate. This cluster highlighted area where poor infrastructure conditions, crime reports issue overlapped, indicating possible intervention points. On the other hand, low-risk zones emerged, showing stable area with a fewer incidents. To present this finding visually, I created a heat map and a scatter plot which provide a clear picture of how crime and service request volumes are distributed across different community areas. This insight can help policymakers, law enforcement allocate the resources more effectively to prevent the crime in the most affected area. Here is a sample cluster analysis visualizations. You can take a look. Moving into the next slide. Key finding and the interpretations. The analysis of 311 service request and crime incidents re revealed several key insights. First, I found positive correlations between the high service request volume and increased crime incidents. This suggests that neighborhoods with the frequent infrastructure complaints such as broken street light, abandoned vehicles, and other tend to experience higher crime rates. While this does not prevent cautions, it highlights the potential role of negligence infrastructure in creating a condition that may contribute to crime. Additionally, the clustering analysis help identify high-risk neighborhoods where crime incident and unresolved service request overlapped. The hotspot indicate areas where improvement in infrastructure maintained could potentially reduce crime. For a policy perspective, this research underscores the importance of addressing urban maintenance issue proactively. By fixing street light, removing abandoned vehicles, and ensuring timely response to 311 complaints, cities may not only improve the community well-being but also enhance public safety. This finding provide a data-driven foundations for future crime prevention strategies that integrate urban planning with the law enforcement effects. Limitation and challenges. While the findings from this study provide valuable insight, there are several limitations and challenges that must be considered. One of the biggest concerns is the correlations versus cautions issue. While the analysis saw a positive relationship between 311 service request and a crime incident, it does not provide that infrastructure issue directly cause crimes. The other external factors, such as socioeconomic conditions and law enforcement activities, could also influence the crime patterns. Another challenge is database bias. As 311 service requests are citizen reported, meaning some neighborhood may report the issue more frequently than other, leading to the underreporting in certain areas. Additionally, missing data such as record lack of local details or response times introduce some gaps in the analysis. A major technical challenge was scalability. The processing large data set require efficient computational techniques. I addressed this by using Apache Spark within the Python, but with optimization, limiting computer power poses a challenges as handling millions of records demanded significant memory and processing speed, which a common computer or the day-to-day use laptop will not have. Future work could involve cloud-based computing resources to overcome these constraints and enable real-time crime prediction model. Talking about recommendations and the future work. Based on my finding, several key recommendations can be made to help to improve the urban safety and infrastructure management. Firstly, for a policy perspectives, cities should prioritize street light repairs, abandoned vehicles removals, and sanitation efforts, especially in high crime areas. Since the analysis reveals a correlation between the infrastructure issue and crime, timely maintenance could help create a safer environment, reduce criminal activities. For future research, enhanced data integrations should be prioritized by incorporating socioeconomic factors such as income level, education, unemployment rates to create more refined crime prediction models. Additionally, applying advanced machine learning techniques could improve crime forecasting and analog detections, making predictions more accurately. Lastly, I recommend the implementation of real-time data pipeline using Apache Kafka or the Spark streaming to dynamically monitor emerging crime hotspot. This improvement could lead to the proactive urban planning and law enforcement interventions, making cities safer and more efficient in the resource allocations. Moving toward the conclusion. In conclusion, my analysis has demonstrated a positive correlationship between 311 service request and crime rate, suggesting that urban infrastructure play a crucial role in public safety. Neighborhoods with a higher report of streetlight outrage, sanitation issue, and abandoned properties tend to experience more crime, reinforcing the idea that environmental condition can influence the criminal activities. To impact of this finding highlights the importance of proactive maintenance by addressing the infrastructure issue promptly. Cities can potentially reduce crime rate and improve community well-being. However, several challenges remains, including data limitations, mm, data reporting bias, and the need of casual analysis. Moving forward, integrating machine learning, real-time analysis, and policy interventions could enhance the crime prevention strategies. By leveraging data-driven decision making, city officials, law enforcement can allocate resources more effectively, making urban environment safer and more sustainable. That is all about the project within this class. Thank you.